Hi, this is Dr. Eric Aidoo. We want to look at the cardiovascular system. The cardiovascular system is basically made up of the heart and the associated blood vessels. So for the blood vessels, we are going to look at superior vena cava, inferior vena cava. Then we look at the major and prominent one, the aorta, and the branches of the aorta. So from left to right, you have the brachiocephalic trunk or brachiocephalic artery, and then you have the common carotid artery, and then the left subclavian artery. That is the arch of the aorta. It is ascending aorta arch, and then the descending aorta, which will go down to the abdomen. So when we talk of the abdominal aorta, it's actually a continuation of the descending aorta. Then, as part of the blood vessels also, we look at this blood vessel, which is the pulmonary part, okay? Pulmonary artery, and it will branch into two and go to the lungs for replenishment, because this will be carrying less oxygenated blood, okay? So the arrow tells you that it is going out of the heart. Then also the pulmonary veins, one on the left and one on the right. So that is also going to come from the lungs, bringing freshly oxygenated blood. So now we look at the heart itself, and we know that it is divided into two major halves with four chambers. So the two major halves will be a right side. So this portion and that portion is right. So right atrium, right ventricle. The other half is the left atrium, left ventricle. So each of the halves is having two chambers. The right atrium is one of the chambers. Right ventricle is another chamber. That is another chamber. That is also the other chamber, the left ventricle. Now, each of these chambers, just like a house, if you want to enter the chamber from the hall, you need to open a door. So the doors that are actually barricading or going to allow entry of blood on the right side is the tricuspid valve. So it's like a gate or a door, tricuspid valve, because it has three cusps. Okay, three cusps, but this is a more or less a two-dimensional structure. So you can't see the three cusps, but you can see two of it, or the valves. The cups are like just like a cup that can contain something. And then the same part of the right side, you have another gate or door that will allow blood to enter the pulmonary artery, and that is the pulmonary valve. Pulmonary valve, right? Anything pulmonary has to do with the lungs. It's related to the lungs. So that's the pulmonary valve, and that is the pulmonary artery, which will branch into two, a left and then a right one, going to the left and right lungs respectively. Okay. Then when we come to the left side, to the doors that will allow blood to come from the left atrium into the left ventricle is the mitral valve or bicuspid valve. Mitral valve or bicuspid valve. Then the aorta also has a door, a valve that opens and closes, and that is the aortic valve. Aortic valve. Because the valve is related to the aorta, it's called aortic valve. This one is also related to the pulmonary artery, so it's called pulmonary valve. And then this one has three cusps, so it is called tricuspid valve. And this one is mitral valve or bicuspid because it has two cusps. So with the heart as well, we can look at two major circulation, either systemic circulation or pulmonary circulation. Systemic has to do with the system. So it's going to the body parts to be used. That is systemic. Okay. And then you have the pulmonary aspect also, which goes to the lungs. Okay. So you can actually tell that for the left side of the heart, when the blood moves from the left atrium, which is actually coming from the pulmonary veins with rich oxygen, gets into the left atrium, the valves will open to allow the blood, as you can see with the arrow, to enter the left ventricle. Okay. Then the left ventricle will contract and pump the blood from the left chamber here into the aorta. All right. So there's a relaxation and then a contraction to allow blood to enter the heart and then leave the heart. So when you look at the fact that blood is entering the left ventricle, it's more of a relaxation mode. Okay, so that is known as the diastole or diastole. And then when the left ventricle contracts to push blood, that is systole. A similar thing happens in the right chamber. When the right atrium to blood that has been used already and almost all the oxygen has been depleted will enter the superior vena cava, and the superior vena cava is bringing blood from the upper part of the body. Then also inferior vena cava will be bringing blood from the lower portion of the body. This blood has less oxygen, gets into the right atrium, knocks at the door, and then this tricuspid valve door will open, allow blood to enter. So that is a relaxation mode known as the diastole. And then when the ventricle contracts to pump the less oxygenated blood into the pulmonary artery, we call that the systole. Now, a question can arise that what are the blood vessels and chambers that are responsible for, let's say, systemic circulation? Okay, so if a question like that comes, what are you going to say? What are the blood vessels and the chambers that are responsible for systemic? So it means that you have to look at which part of the blood is doing anything related to sending blood to the body part or receiving blood from the body parts. Okay, and not taking blood to the lungs. Receiving blood from body parts and taking blood to the body parts. So you should be able to tell. This superior vena cava, inferior vena cava, and then right atrium are going to receive blood from the heart. From the body part. So that is systemic. Okay. Right ventricle, once it pumps blood, is serving the lungs. So that is not systemic. That is pulmonary. Okay. That's pulmonary circulation. Then you can also tell that the left ventricle and the aorta are going to serve the body part, so that is also systemic. However, the left atrium and the pulmonary veins are receiving blood from the lungs, so that is not systemic. So you can work that out. Okay, so I've given you the background. You can work them out and then list the structures involved for systemic and then pulmonary. So as it is indicated here, the cardiovascular system consists of the heart, arteries, veins, and capillaries, which will make up blood vessels. So this is also a vertical section through the heart, showing how the aorta ascends and then arches. Okay, so blood will definitely be going through that. Obviously, it has to go through the aortic valves before it enters the ascending and then the arch. And you can see here at the arch of the aorta, you have these three branches. That's the brachiocephalic artery, common carotid artery, which is the left one, and then subclavian artery, also the left one. Okay, because this part is related to the left part of the heart. Now, the cusp I was talking about, okay, is, which will form the valves. It looks like something like that. And even more clearly like this. So it's formed something like a cup, the cup for drinking water or whatever. But when you look at it from the top, you see that this is more like a convex, structure with a hollow or lumen, not a lumen per se, but there's a depression. Okay, so it's like a fossa inside it. Right. These are tendinous structures that hold the valves. All right. So basically, that is how the heart looks like. These are papillary muscles that will hold these tendinous structures. Okay. Which will either allow blood to enter or not. So when they close, you hear a sound. Okay. And then when the aortic and then pulmonary valves also close, that one also makes a sound. But the sounds that that is the between the aorta and ventricle, the valves make a louder sound. So we are talking of the tricuspid valves and then the mitral or bicuspid valve. They make louder sounds than that of the aortic and then pulmonary ones. Okay, so you usually hear a lap dab sound, a very high sound, and then a low sound due to the closures of the valves. Okay, so the higher sound will be for the tricuspid and then the mitral valves, and then the low sound will be that of the pulmonary valve and then the aortic valve. So basically, that is what it is. In the superior vena cava, that is going to open into the right atrium. Inferior vena cava is also going to open into the right atrium. So there's a common opening there. Then obviously you also have the right pulmonary artery, and then you have the left pulmonary artery. These are sending blood which has less oxygen to the lungs to be replenished. That is a right pulmonary vein carrying rich oxygenated blood from the right portion of the lungs. Remember, the lungs has a left portion and then a right portion. We'll be looking at the lungs after the cardiovascular system, and then you can link the two. So that is the left ventricle. Obviously, the cardiac muscles here are thicker than that of the atria. Okay, so note that as well. So pulmonary and systemic circulation, as I've mentioned already, if we take the heart as the right chambers, those are the right chambers and these are the left chambers. So blood coming from the inferior vena cava will enter the right atrium. Those coming from the superior vena cava will also enter. The tricuspid valve will open, and then blood will come into the right ventricle. Right ventricle will pump or contract at systole to push blood through the pulmonary artery that will go into the right lung and then the left lungs. So those are the lungs there. So that is the left one, and then that is the right one. And you can see a capillary bed here. Once the deoxygenated or less oxygenated blood comes here and one has breathed in fresh air, it will be exchanged. Okay, and then freshly oxygenated blood will now go through the pulmonary veins and then enter the left part of the atrium. This is also coming from the left side of the lung, so left pulmonary vein, that is right pulmonary vein. When we are using left and right, you should know that we are looking at it with respect to the diagram, not you watching from the screen. If you are watching from the screen, that will be your right side, that will be left. But we are looking at the diagram facing us, as if the diagram is rather looking at us. And if it's a human being, that will be the right side and that will be the left. Okay. So the pulmonary veins will bring highly oxygenated blood into the left atrium. The blood will knock at the door for the bicuspid valve to open, and blood will be collected into the left ventricle. When the left ventricle contracts, okay, the pulmonary valves will open, and then blood will be pumped into the system. Now, once blood is pumped, the valves, the pulmonary valve, have to close. Okay, they have to close so that blood does not come back into the left atrium. The same applies to the right side. The pulmonary valves have to close to disallow blood from getting back into the right ventricle, and that will make the soft sound when they close. Okay, and also the bicuspid valve have to close when it's systole. That's when the left ventricle is contracting, to disallow blood from getting back into the left atrium. So the bicuspid and tricuspid valves also close during systole. That's when the two ventricles are contracting, and that makes the higher sound. So it's as simple as that. So this portion will be the upper portion of the body, because aorta is supplying this through the brachiocephalic. So brachiocephalic is going to the brachium and the cepha, which is head. So upper limbs and then the head region. Okay. Then you also have the common carotid, which will be going towards the head as well. And then also the left subclavian going towards the shoulder region. And then the lower portions too are here. So that is, in simple terms, how the circulatory system works. When you cut through the blood vessel, this is what you see. It's a tunic, or it's like just a PVC pipe. So there's a lumen inside, and then there's a body around it. So the body of the vein is such that it has wider or larger lumen compared to its counterpart artery. And then also the vein will have less smooth muscles, that is in the tunica media, compared to the tunica media of an artery. There's more smooth muscle, and then also elastic fibers there. So that is a valve, for instance. So the veins also have valves to disallow blood from moving by gravity downwards, because there's little pressure in the veins. So you can see another valve there. Okay. Then that is a venule. So from a bigger vein to a smaller vein. So large vein, medium-sized vein, and then a venule. Then you have an elastic artery like that of the aorta. Then you have muscular artery there, and then the arteriole. All right, so just know these differences. So the innermost layer will be the tunica intima, followed by tunica media and tunica externa for both the arteries and the vein. So here to tunica intima, tunica media, tunica externa. Okay. And that's what you have to know for now. This is a longitudinal section. So you can see the tunica intima there, made up of the endothelium, which is the lining epithelium of the artery or the blood vessel, subendothelial layer, internal elastic lamina. That's the tunica media, made up of the smooth muscles and elastic fibers. Then that is the tunica externa, and that is the vein. So you can see the valves and what is forming something like the cusp, okay, the collection point when blood is supposed to drop down to some will collect here, because not all will leave, but you want to prevent it from getting down. Okay. So you can see that the tunica media here is larger than the tunica media here. Smooth muscles are less in the valves. And there's a larger lumen here in the vein compared to that of the artery. So we'll look at the respiratory system in our next video. Thank you very much, and I hope this video helps.